Hey everyone! In this video we'll have a look at corrective shapes in Houdini, which are used to correct deformation problems due to volume loss in deformation or simply undesirable deformation that occurs during bone, Blanchett, or any other deformer deformation. Usually when we reach the point of a bad deformation, we create a corrective shape that is blended on top of this deformation in order to get the final shape we want. We will look at two different workflows, Blanchett and debone deform. There's a slight difference between the two, because the second one requires an inverse skinning deformation. With that said, let's start with the Blanchett workflow. Here we have a typical Blanchett setup. We have a default or neutral shape, which is our head. We have two Blanchetts, mouth corner out and mouth corner up for driving the mouth corner in different directions. And we have a Blanchett node that blends between different shapes. As we can see, when both those shapes are at 1, we have a loss of volume in the cheek area. To fix that, we have a series of point edits, which together form a corrective shape, which will be used when both of these Blanchett values have the value of 1. And for our first scenario, we want to create a simple edit node, which contains all the correct information that we can plug into one of the Blanchett's node inputs. To create this node, we will use a export command called subcreate_edit. And let's open our export panel and first go into our geometry object. The first parameter is going to be the name of our new node. So we just call it corrective shape. The second parameter is our uncorrected shape, which is Blanchett's face. And the last parameter is the corrected shape, which is mouth corner edit. After running the command, we have created the edit node. And as we can see, it contains all the information we need. At this point, we can delete these corrective edits because we don't need them anymore, because all the information we need is now in this edit sub. Now, all we need is connect the input of our edit sub to our neutral with shape, which is the head, and the output to one of the Blanchett's input. Now, if we set the value of corrective shape to 1, we see that the Blanchett output is now also taking into account the corrective shape, and we have the correct shape when both Blanchetts have the value of 1. All we need to do now is drive the corrective shape in a way that it will have the value of 1 only when both mouth corner out and up are also 1. To do that, we will write an expression. So let's open the expression window for our parameter. What this expression does is that it basically checks whether or not the mouth corner is going in the diagonal direction and how far it is going, and calculates the value of the blend shape based on those two parameters. So when both parameters are causing the mouth corner to go into a diagonal direction, it will raise the value, but when only one is raising value, we will not see a difference in the value of the corrective shape. As we can see, we have created a simple edit node with blend shape expression that drives the corrective shape. For our second option, we can use the shape difference node. As the name implies, this node calculates the difference between two shapes, which in our case is the combination of two blend shapes and the corrective edit shape. First, let's create the shape difference node. We should connect the output of blend shapes to the first input and corrective edit into the second one. So let's just rename it to like corrective shape. Now the difference method should be post-deform. Now if we look at the result of our corrective shape node, we see that we get sort of an odd shape, and this is actually fine. This is because the corrective shape only stores word space difference between two shapes. So the point difference is stored in the point word space position. This means that if we create a point triangle and add point positions from the corrective shape to the blend shape, we should get the corrective shape result. So let's just rename this to corrective shape sum. And now, as we can see, we have a correct shape. So what we need to do is connect it to our blend shape setup, but we cannot do it because the output of our blend shape is the input of our shape difference node. To create a proper deformation order, we're going to create a copy of our blend shape face node, which will have the blend shape values set at the position in which we are creating the corrective shape. In this case, both blend shape values will be 1. So now let's reconnect some inputs. The corrective edit should go into blend shape corrective, and we're looking at the difference between these two. And for the wrangle, we have to take into the default shape, which is our head. And now we can connect the output of this point wrangle into the blend shape face up. And now we can copy and paste our expression. Which is the same as we had in the soft-create edit example. So, as we can see, the results are the same. The only difference is that now we can make additional edits, and the results will be updated automatically. Whereas with soft-create edit, we have to constantly call soft-create edit to create a new edit node and create the updated version. just one note regarding how to incorporate this into a rig. So the only two parameters that are being animated or connected to the outside controls are these two in the Blanchett phase. This one, Blanchett corrective, will always be set to 1 and will not be animated or anything because they are only used to create this corrective shape. So these are two options for the Blanchett workflow, and in part 2 we will look at the bounty form workflow. Bye bye.